everyone, this is Amarnu. Today we'll be going through our lab assignment for Introduction to AI, and the objective of this assignment is training a data model according to two models, which is linear regression and decision tree training, and then observing which model is better. So if going through the sequence of the steps, first step is loading the data, fetching the data from the dataset, which from a GitHub repository, which is already provided in our assignment. Then we'll try to handle the missing values, we'll print few graphs, few scatter plots, and then finally we'll apply model training and evaluation to our dataset. So starting with the task one was signing into Colab, and then moving to the task 2 is downloading the dataset. We have created housing paths and stuff, and then we are printing housing data's information, and then we are printing housing.head. Housing.head usually gives us 5 rows, but housing.head 6 gives us 6 rows because it's already specified. And then this is housing info, and then we are printing the value counts with respect to ocean proximity, and then it's housing.describe. Moving on to the matplot library, which is used to print graphs, scatter plots, and histograms. So we're using that, and then the bin size 50 means that each gap would be of 50, and the figure size usually describes the size of each graph, which is 20 by 15. Is training the dataset. So the first step in training a dataset is dividing the dataset into training data and testing data. In this specific assignment, we have used the ratio of 80 to 20. So 80% is training and 20% is testing the data. First method used to split the data was a random method, which is actually not very efficient and correct. So if I run this code, you can observe one thing, that every time these values changes. Now the top value is this, but if I run this again, you'll get something else, which means that my observations and my model could be biased because the splitting is not uniform. Instead, we use stratified splitting, which is more efficient and more helpful for our model. So we are dividing our model into these bins, which is 0, 1.5, 3. So each category, so the first category is 0 to 1.5, second is 1.5 to 3, and so on like that. And then labels to those categories are given as 1, 2, 3, 4, and 5. This is more efficient to train our data because the splitting is uniform. So training set and testing set will have uniform distribution of all the data. This is stratified shuffle split. We're printing the same data, and then we'll move on to visualizing the data set. So the first step in visualizing is creating a copy. Because if we don't create a copy, maybe our data can get harmed if we apply some methods to the same. Now the first step was just printing the scatter plot. If you see, this is the same scatter plot, but here you can observe dark and light densities. That is because of this thing, which is alpha 0.1. So alpha, when we specify alpha 0.1, it gives us the chance to print data. It shows that at which point the population and the data is denser. So for each data point, it will overlap and it becomes darker. And then next is a bit advanced scatter plot. So in this one, if you see, the radius of the circle gives us the population size, and then the color shows us the color shows us the price. The circle represents the population, color shows us the price of the house, and then if you see these red dots, this shows us the area where the houses are most expensive. This is the best way to represent data in a scatter plot because this is very self-explanatory. And then we'll calculate correlation. So correlation explains that how each factor affects my objective, which is median house value. If the correlation is 1, it means that if median house value, if that one factor is increasing, the other will increase as proportion of 1. So the lowest are total bedrooms. For total bedrooms, it's 0.04, which means that total bedrooms is not really affecting the house price. And then if you see, there are a few values which are negative, a few which are positive. So positive means that with increase in those factors, my median house value is also increasing. But if it's negative, like for population and longitude, it's basically inversely proportional. So if population is increasing, median house value is decreasing, and vice versa. Moving on to plotting. Yeah, so from this graph, you can see that median income is the most promising factor to finalize the median house value and to train our model. Also, in the next step, we are trying to print scatter plots against each category. So here we have like 11 aspects of the dataset, and if we print each aspect against each other, it would be like 121 scatter plots, which is too much. So we are just focusing on these 4, which are basically the ones with the higher correlations. So it's median house value, median income, total rooms, and housing median age. So those are printed over here. And then we are just focusing on median income because that is the most promising factor which affects the house value. And if you can see, the correlation is pretty much high. And then in the next step, we are trying to create more categories based on the categories which are already provided to us. For example, we have created rooms per household. So this would increase the columns in my data set, and these are all derived from the already existing columns. And then we are trying to calculate the correlation for all of these. Moving on to the task 5, which is machine learning algorithm. What happens is that whenever we are provided with a data set, there are a few values which are missing. So here we'll try 3 techniques to reduce the ambiguity in the data, and so that our model works more, so our model is more efficient. The first step is removing the whole row which has missing data. The second one is removing the whole column, and the third one is using median to substitute those values, which is also known as single imputer. So this is what has been done over here. 6, which is model training and evaluation. As already mentioned, that in this data set, for this code, we are using two models. The first one is linear regression, which is already used over here. If I print the data, these are my predictions, and these are my already present values in the testing data set. So which means these are not really pretty much close, and my model is not working right. And then we need to print mean squared error, which comes out to be 68627. And then if I move on to the second model, which was decision tree regressor, it gives me and then my root mean square error comes to be 0, which is a sign of overfitting. Yes, so in decision tree regressor, what happens is that the data is categorized, and the model tends to memorize each and every category. So it will categorize data into yes or no things. So it will go through the yes part, and then for no, it will again categorize itself. So it basically memorizes each and everything which is given to the data, which is a case of overfitting basically. That's it for today's lab. Thank you so much.